So our final video for section 6.1 and 6.2 is just going to cover some additional problems that I'd like to solve. I want to remind you that these videos cover 2 days worth of material. That's why their total runtime is a little bit longer than usual. But so just keep that in mind. So the first kind of hodgepodge problem that we're going to do is finding the area of a triangle when you don't have base times height. So keep in mind to find the area is 1/2 base times height. Well, if we can't do that, let's say we're given a triangle that looks something like this. A, B, C. You can also use this formula. Area equals 1/2 A times B times sine of C. So this is a situation where we're kind of given SAS, and you can find the area. Alternatively, you can, replace these. You could have A times C, and then you would take sine of B, or you could do B times C and then sine of A, right? So that's pretty cool. For example, if I wanted to find the area of a triangle, let's say it looked like this, 54 degrees, 40 inches, and 30 inches. All you'd have to do is plug this in to the formula. So you'd have 30 times 40 times sine of 54 degrees. So let me go ahead and plug that into my calculator real quick. 1/2 times 30 times 40 times sine of 54 degrees. So I get about 485.4. And it'll be inches squared. So that was just another formula for you. We now have an area formula. The next hodgepodge problem I want to do is I want to go back to a problem we solved a while back involving 2 fire towers, and I want to show you how we could do this with law of sines and cosines instead. So let's say we have 2 fire towers, and they're 10 miles apart. I'm going to kind of summarize this a little bit. We'll say Tower A is west of Tower B. A fire is a bearing of 76 degrees from Tower A, and the fire is bearing 304 degrees from Tower B. How far is the fire from Tower A? So Tower A is going to send out a crew to deal with this fire. How far is it from A? So we'll go ahead and draw that picture. We have A, we have B. From north, this angle is 76 degrees. For B, this angle is 304 degrees, and the fire is somewhere up here. And then I know this is 10. Using what we know about right triangles and rotations and such, this angle has to be the complement of 76, so that's going to be a 14-degree angle. This angle is 304 minus 270, so that's going to give me 34 degrees. And so then the question I'm trying to answer is, what is this distance? So I'll just call that lowercase d for distance. So if you take a look here, we actually are given ASA. So that means that this is a law of sine situation. I could find this angle using my knowledge of the sum having to equal 180. So if we do 180 minus 14 minus 34, we end up with 132 degrees. And so then using the law of sines, I would just say that 10 over sine of 132 degrees has to equal my distance over sine of 34 degrees. So this turns into a much simpler problem. I'm going to type this into the calculator really quick, but it turns out to be much simpler than what we did before in section 4.8, I think it was, if you take a look back at that. So I get about 7.5 miles, 7.52 to be a little more precise, but we'll go 7.5 miles. So pretty quick when you're using law of sines and law of cosines. And that actually concludes the two I wanted to do. I think I'll make one more video for kind of an optional derivations video so you can see where they come from. But that is the end of the main content for law of sines and cosines.